start the recording now. Okay, so thank you for that prayer. You know, it's interesting. You mentioned, Mia, that we could gain the knowledge in order to get good grades, do our homework, and everything. That is actually, if you wish, the short-term objective here. Okay, it is certainly an objective, especially for you. You are doing school and everything. But one of the questions that I have for you, all of you, is why do we study geography? Okay, what is it that we gain with the study of geography? Okay, think about that, and you can write your answers, your feelings there on the chat. One of the things that I get, okay, is actually a sense of understanding where I am. All right, so it's for me is an understanding of really feeling that I am part of something and I know where I'm standing. Okay, understanding the geography of a place and everything is important for me because of I get a sense of orientation, of belonging, okay, of knowing where I am. So that is one of the reasons why I love studying geography. In fact, I love it, for example, when I got the opportunity of going to England, okay, the first time that I went to London, I had actually, you know, from reading and looking at maps and studying really the geography of England, even when I was in elementary school and everything, when I finally got there, I felt right at home. Okay, still there were some things that were kind of weird, but I wasn't surprised. I wasn't lost. I didn't feel that I wasn't, you know, in a place that was totally unknown. I was able to orient myself easily, and I was able to find, you know, Hyde Park and Buckingham Palace and Nelson's Square and so on. All those places were kind of, if you wish, familiar places, even though I was seeing them myself for the first time. Okay, so that is kind of the objective. One of the things that I want you to strive for is that in this year, as you learn on European geography, and especially the country that you've chosen, that you get to really know these places, so you feel very familiar with them. Okay, so you get this sense of belonging. All right, so today we are going to talk about some of the mountains and how mountains are formed and so on. We will talk more on that on the science class when we are doing the geology unit. Okay, but for now, the most important thing to understand is that mountain ranges are actually formed by the geological movement of the Earth. So the Earth, even though we don't notice it, is always kind of moving, sometimes slowly, sometimes faster. Some of the changes take time, go over long periods of time. Other changes are a lot faster. They are, catastrophic, if you wish. Yes, I'm recording this, Rodney. Okay. I hope I'm recording. Let me check. Okay, yeah, I'm recording it. All right, thank you for the reminder. So, for example, some of the movements of the tectonic plates are really slow, and they happen very slowly, but their effect is that they cause parts of the Earth to actually lift up over time. Okay, sometimes this is slowly, sometimes the movements are more violent. All right, for example, when you have a volcano eruption, that happens really, if you wish, all of a sudden. Okay, it's a large change in a short period of time. Okay, so Other times you have volcanoes like in the Hawaii Islands that are going on constantly, and so they are in the middle of the ocean, and they keep moving the layer, of the earth underneath keeps moving, and that is what forms the chain of the Hawaiian mountains. Okay, it is. Oh, okay. So I get to use a bigger computer. All right. Okay. Excellent. So, all right. That's right. So the Rocky Mountains is one example of that. Okay. So this is kind of, if you wish, the depiction of how the Rocky Mountains happen, and for that matter, all the Andes Mountains. Okay, so all the western side of the American continent is really formed this way, where you have one layer being subdued, being taken down, okay, and another one is pushed up, all right, and that is what forms the Andes Mountains, the Rocky Mountains, all the mountain ranges through Europe. The Himalayas are also formed in the similar way, as you have the continent, the subcontinent of India, okay, being pushed against the China plate, and that raises the mountains up, okay? So yes, so we are, in Bolivia, you are right in the middle of this area being lifted up very slowly, but it is still moving, okay? And so that is how mountains are formed. In the middle of the ocean, you have the ocean ridges that divide the ocean, and actually they are, slowly they separate the oceans. And so you have that, for example, the Atlantic Ocean that has a very large ocean ridge, increases in size about 2 or 3 centimeters, okay, per year. So about this much per year. So it's very, very slow, but it's a significant movement, okay? So again, sometimes the changes happen slowly, other times the changes happen fast, all of a sudden, like in the cases of volcanoes, or when you have earthquakes. The pressure between the plates colliding accumulates, and then all of a sudden that pressure is released, and a big change happens all of a sudden, and it manifests itself in the form of an earthquake or a new mountain or crack. How is that movement recorded? That is a great question. So nowadays we are able to very accurately record the movement of the tectonic plates using the GPS satellites. So the satellites in space, they basically beam, they measure the angle, and it's all based on trigonometry. Okay, so it's all based on the measurement of triangles. So you basically have two spots on the Earth, all right, and a satellite up there, and you can measure then the triangle between those 3 points. Later on, if you measure again, if the angles change, okay, then one of the sides of the triangle has changed, And so that is basically the idea of how that is being measured nowadays. Okay, so it's a fascinating thing, but that is one of the main reasons why you need to study trigonometry in math. Okay, so one of the most useful disciplines of mathematics is trigonometry. Yeah. So it is actually pretty fast if you think, 3 centimeters per year in the Atlantic Ocean, all along the Atlantic Ocean. That is a lot of movement, okay? So as mountains are being formed, also you have processes that erode the mountains. So the process of erosion is what basically makes mountains, you know, lower, okay, but sometimes the process of erosion also makes the valleys and the mountain valleys in between. There are several erosion processes. So about an inch, excellent, yes. So hills, you know, Rodney, you ask about hills. Hills are basically the remnant of all mountains, okay? So you can always tell how old or new, relatively, you know, talking in geological ages, how old or new a mountain is depending on how high it is, also how rugged the mountain is, okay? So you have that like the Rocky Mountains or some parts of the Andes Mountains are very, very rugged, okay? The Rocky Mountains are, you know, the rocks are really always sharp, okay? And that shows that they are relatively new in geological terms, okay? And so other mountain ranges, for example, in the east of the United States, the Appalachian Mountains, they are still called mountains, but they are actually more large hills, all right? And the rocks there are not as sharp. They are not rugged. They are more rounded, and so on. And that indicates that there has been a lot more erosion happening over time, and the mountains are lower. Okay, so you can always tell how how old or new the mountains are by that. You can also see in this slide the process of erosion. As the material from the mountains is eroded, it is being deposited in the valleys, and that forms actually new land. So the land, also the valley floor, also continually changes as land is being deposited, okay, and that increases the valley areas, all right? So yeah, the Rocky Mountains are babies. They are actually young. So which mountains do you think would be the youngest mountains that we have? Okay. All right, let's see what you can think of that carefully. Okay, which mountains would be the youngest mountains? The mountains in the New England area are older, right? Yes, yes. So those mountains are older. Okay. So volcanoes, of course, that active volcanoes are the newest mountains. All right. So Ben, what would be the newest mountains that you have there in Hawaii? Okay. So the active volcanoes are the newest mountains of all because they are actually in formation as we speak, literally. All right. So Mauna Loa is the one that is active. Okay. Mauna Kea is not active in the island of Hawaii. All right. And then you have that in the other islands also the volcanoes are not active. So they basically have this process, all right, where the hotspot of rising magma is being moved, and that forms, you know, as the land moves underneath, the older Hawaiian islands become extinct volcanoes. Okay, so in the Hawaiian Islands, the process is actually this way: is going from the movement is actually going from west to east. All right, and so the hot spot is continually moving east. Basically, the mountains, the rest of the continent is, you know, the plateau there on the Pacific is moving west. Okay. So you can find out how old the mountains are in geological terms, okay? But so all the mountains that we have here in the western United States are pretty new, relatively new, okay? So let's go and see some of the features of Europe in particular, all right? Yeah, in geological terms, you are always talking about millions of years, so that is really because all these processes, most of these processes take a long time for them to happen, okay? So we have here the topography of Europe. This is just a physical map of Europe, and you see here the Ural Mountains. The Ural Mountains, they are the part, okay, that joins Europe and Asia, and is the division between the two. How do we know that? Meaning, how do we know how long it takes for the mountains, or when? That is a great question. Okay, so one of the ways to know that, okay, is basically by looking at how, so again, you can nowadays do quite precise measurements, okay, and you can tell how fast the mountain is moving, all right. So let's suppose that you measure, again, with GPS, satellites and so on, you measure that, let's say, the Rocky Mountains get higher, okay, by 1 inch a year. All right, I don't know how it is, how fast it is, but if you that's right. Okay, so you take into account how fast they move up. Also, you can measure the erosion. Okay, you can measure how fast the valleys are moving down. So the valleys between the mountains and so on, that also would change. All right, but then you extrapolate, again, using mathematics, using proportionality. You say, all right, if it takes this much to rise in 1 year, okay, and the mountain is this many, feet tall, how many years it would take? Okay, when did this process start? All right, and so with that you can extrapolate and see the process of formation. Okay, so also, and yes, yeah. Mm-hmm. Mm-hmm. Okay, that is an excellent question. So there are sometimes evidence of sudden changes. Okay, so for example, erosion, can happen fast or slow. All right, and so if you have a valley that has, a river in between, and it's kind of meandering, and there's not a whole lot of movement now, you can tell, okay, this has happened over a long period of time. Okay, but if you have a mountain that rises up, all of a sudden, and then there's another part of the mountain down, and you can see the layers of the change, most likely that change, that abrupt change, happened actually quite fast. Okay, geologists are able to measure or estimate, if you wish, when did that happen, depending on the layers that they see on the mountainside. Okay, does that make sense? Mm-hmm. Excellent. Mhm. That is a good question, and it really depends on the rock type. We are going to talk more about that probably in the science class when we get into geology. But you probably remember about the different types of rocks, sedimentary rocks, the metamorphic rocks, and the igneous rocks. In the in the science class, we haven't yet got into that unit. Okay, that is the second part of the year is geology. So we are doing astronomy now in science. The next part of the year will be geology, and we'll talk more about that. Okay, but you can actually think about it, about these processes. This is a very important thing to actually think about. All right, so you have that the igneous rocks. They are the rocks that come from volcanoes. How fast do those form? Really fast. Yeah, because usually those are the rocks that are spewed out of volcanic eruptions. Okay, that can happen really fast. How about the metamorphic rocks? Granites, like the ones that we have here in the Rocky Mountains. Okay, in some areas of the Rocky Mountains that are very, very strong. Okay, they are formed through pressure, okay, and then they come up through these movements on the earth crust. Mm-hmm. Yeah. Mm-hmm. All these rocks are formed by actually several layers of other rock being on top. Mm-hmm. Uh-huh, yes. Mm-hmm. Yes. Mm-hmm. No, it's all a matter of estimation. Okay, I don't know that is really they are models. Okay, that the geologists build in order to predict that. Okay, and they basically analyze the density of the rock, how tight the molecules of the rock are together, and then you can estimate the pressure that they must have had. Okay, when you estimate the pressure, then you can also estimate how many layers deep, what material would have had to be on top in order to exert that pressure underneath. Okay, and then you have to estimate, okay, what would have taken for this to come all the way up? All right. The softer layers are eroded, of course, and the harder layers are harder to erode. Okay. So that is kind of the process. Europe is a very interesting story, really, because if you see here the map of Europe, you can tell, okay, here we have the Pyrenees, all right, a place where two plates are certainly colliding, okay. These are high mountains. The Alps are the highest mountains here in Europe, okay. You see another chain of mountains here, the Carpathian Mountains, the Pyrenees in the middle of Italy, okay? And then you have these other mountain ranges in basically in the west of Serbia and all of Greece, all right? And then you have, these are much older mountains in the southern part of France, the Central Massif, but they are much lower, all right? The same thing with the mountains in England, okay? The mountains in Scotland are newer. And then you have this mountain range here in Norway and Sweden, okay? And this one is very interesting, the mountains here in Norway, because the erosion of these mountains is made basically by glaciers. All right. Also, over time, the glaciers accumulate snow and they move through gravity down, okay, and they carry a lot of rocks and materials. With all the pressure of the ice on top, it moves down and it erodes and it forms what is called the fjords. All right, so let me see if I have here. This is a picture of a Norwegian fjord. Very, very large inlets. This is not a river, this is the ocean going in, but this break into the mountains was actually made through glacier action. Okay, exactly, it's like a plow. That is exactly right. So Norway is mostly mountains, and it's mostly fjords. The coastline of Norway is mostly that way also. So very, very unique formation here in Norway and in Iceland. Iceland has very new mountains because Iceland also has a lot of volcanic activity. So the Atlantic Ridge, remember that we were talking about how the Atlantic Ocean keeps expanding and everything. The Atlantic Ridge actually comes up there in Iceland, and that is what causes the Iceland active volcanoes. All right. Another important feature to notice, yeah, it's like frozen, exactly. Another feature to notice is that these mountains, as the mountains erode, the material from the mountains is transported by the rivers and makes all these plains. So all the plains here in Europe, all right, is basically formed by the erosion of the transportation and erosion of these older mountains that form the continent, basically. One of the areas here in the Netherlands where we see that process, very, very well in action is right here in the Netherlands, okay, the lower lands, where you see that the Rhine River carries a lot of material from the Alps into this valley, and it actually creates new land. All right. But all the areas where you see the land being deposited, that is how the process of erosion forms those areas. Okay. Does that make sense? Here I have another map. This one has kind of a label in there, but this is kind of the type of thing that it's just a little village. Oh, okay, excellent. I didn't know that, Haley. So this is kind of the type of map that I would like you to do as part of the assignment. I want you to grab a blank map of Europe, all right? Just a blank one, no labels and everything. And I would like you by hand, not printed or anything, just by hand with a pencil and color pencils and so on, make all the physical features that you can of Europe. All right, so you can draw the rivers, draw the mountains, label them, all right, and put also labels to the different sea coasts, the gulfs, the seas, and so on. As much detail as you would like to put in an empty map of Europe, all right? And then you can do that also for the country that you are studying. Yeah. So I don't know if this is Sam or Annika. I think that this is probably Annika under Sam's account. Okay, so you said that you did that when you were in Ukraine, and it took forever, but it was really fun. That's right. Okay. So, okay, and Sam is Christina. Annika is Sam, and I'm going to get all confused all the time. But anyways, so I remember doing this type of assignment for almost every country of Europe when I was in elementary school, and I loved it. I still remember really all these things from drawing those maps. So in the country map, I want you to be very detailed in the different features, okay? Here we have another example. So there's lots of sources that you can take for doing this type of map, all right? So here you have the North European plains, the Central Uplands, the Carpathian Mountains, Baltic Mountains, and so on. Okay, so you label all these things clearly, all right? Then afterwards you scan the maps and you submit them as scanned copies, okay? I don't have a due date for these things. Let's do the due date before the Christmas break, okay? We're going to have a Christmas break in December. Before that, all right, let's upload this assignment. Fair? Here I have just a physical map, if you wish, of the Central Europe area, all right? And you have the different plains, the rivers. You can see the delta of the Danube River, all right, and the Dnieper River here, all right? So I would like you also to learn by drawing and very carefully as you can, to draw the rivers and all the lakes, all the things that you can think of for this map. Here we see Western Europe. Western Europe is also, it has mountains, you can see over here in this area, but they are actually very old because they are very low, much eroded. Let me get the pen and kind of highlight this part. Can you see this area? It has some mountains, but are very, very low. Then you have here in Finland the area of glacier lakes, all right? So all these lakes, there are thousands of lakes in Finland. They are mostly formed by the process of erosion through glaciers. Okay, the similar in Sweden. They are freshwater lakes, yes, they are freshwater lakes. Is Annika, Sam, could you help us? Is there a lot of fishing in these lakes? Is there a lot of fishing in these lakes? I imagine, it seems that is the case. I know that Finland is covered with forest, very, very green in there. So let me know what you know about fishing there. Northern Europe, we were talking about the fjords, all right, and the process there of glaciation. The volcanic processes in Iceland, all right? So not totally sure. So you were very young, someone you were there. Okay, that's fine. So, but you see that there's lots of lakes really in that area. Southern Europe is different in the sense that there's more erosion here from precipitation, all right? So you don't have a whole lot of glacier action. In the higher parts of the Alps you do, but here the process is mostly the erosion from water, okay? And the weather is warmer, much warmer in Southern Europe, of course. And you have, let me see here, I have a picture of a Mediterranean beach, all right? Oh, wow. So, okay, so let's see. My dad went swimming. He had to break the ice. It was kind of funny to hear the stories later. Oh, yes, Yeah, so this, of course, the Mediterranean coast of Europe is one of the most beautiful places in the world, you know, for vacation and everything. So hands down, this would be the place to go. Okay, I think that probably Hawaii is better. Sorry?
None of the people are in the water, and there's like a little bouncy ball floating out there.
Yeah, there's a little buoy here, probably indicating a swim area. You know, that is kind of how they are. Yeah, I would be swimming.
It's very difficult.
Yeah. Yeah, it always my charity says it almost makes me want to leave Kansas. Yeah, I could leave Kansas for the Mediterranean coast. All right, once you become a marine biologist, you want to go there. Also, I suggest going to Hawaii if you are a marine biologist. Oh, there are so many places to observe and do snorkeling and everything. So that is awesome. Let me see if, okay, so those are the slides that I have here for the class. So we talk about the different types of erosion. We talk about how mountains are formed and how you can tell, you know, the newer mountains from the older mountains. Of course, you know, you can see that through this is that the Himalayas are very new. They are also in the process of forming. They are the highest mountains in the world. So all that area is relatively new also. Okay. So let's see. I have some resources that I found here in Wikipedia. There's a list of mountain ranges. Okay. And again, different mountains. There are some articles that you can read about different types of erosion and so on. Avalanches also, that reminds me, is also another way of a sudden change, okay? A sudden form of erosion. All right. Yeah, are they highest and tallest or just highest? I don't understand the difference, Haley. The Himalayas are highest and tallest or just highest? So let me see if I understand. You mean from the ocean floor to the top, that would be height, okay, the elevation, you know, and so they are the highest. So you have that the highest mountains in the world, okay, are there in the Himalayas. All right, the Andes also are very, very high. If you are talking about tallest being from the not from the sea floor, not the sea level, meaning sorry, the sea level, but from the foot of the mountain, if they are tallest. Okay, I think that considering that, the tallest mountain would be the Mauna Loa, okay, in the island of Hawaii, because the mountain is really just one continuous volcano going from the sea floor. So it's you know it's actually much higher than Everest. Does that make sense? Okay, excellent. All right, good deal. Thank you for asking questions. This makes it a lot funner. All right. I like here to show you in this animation of the mountain formation. Okay, so here you see kind of an animation of how you have a fault, all right, that could be created by an earthquake or something else, you know, and then as pressure builds laterally, it pushes the other layers up. Okay, so that would be one example of how mountains are formed. This is a very cool article that I invite you to study, and I have the link there of this in the lesson. Okay, let's see. So here we have also an article of mountains. So one side is less drop off than the other. Yes, so as you saw there in the animation, okay, one side usually is kind of, you know, slanted. The other side is an actual cliff, it can be. So you can see there in the animation how that happens, but we can actually see that here in the western, in the Rocky Mountains. You actually can see that. Let me see if I have pictures there of the Wasatch Front. Okay. All right, let's see if they have some pictures of the mountains themselves. But no, there's not very good pictures there. Okay, let's see, Wasatch Range. All right, somewhat. But there are some areas here in the Wasatch Mountains where you can see the break and the layers, okay, of the mountains. Really, so this would be the break side, okay. And of course, you have the Wasatch Fault that runs through the foot of the Wasatch Mountains here in Utah, and that is the other part, okay. So again, if we go here to the animation, let's see if we can go back to this animation. So here you have the Wasatch Fault. All right, here you would have the Utah Valley or the Salt Lake Valley, and then you have here the Wasatch Range Mountains, and on the eastern side you would have the area where you have the ski resorts and everything, Park City and so on. Okay, so this part, it would be too steep to ski. All right, but this is the area where you can do the skiing. But the Wasatch Fault is a very real fault. My brother lives very close there to the Wasatch Fault, and in fact, one neighbor of his, he bought a lot right above where my brother lives in southern Provo. All right, and when he was trying to build a house, the foundation kept cracking. Okay, and they found that his lot was right on the Wasatch Fault, so there was nothing that they could do. They tried to put pylons and everything, but this was a break on the ground that literally went through the crust of the earth. So there was nothing that he could do to build in there. Earth rules again. Yes. So you have to, whenever you are going to buy a piece of land or something, you need to be aware of what is the geology of the place. You need to actually know where am I buying this, because you could be buying a piece of land right on a fault. You don't want that. Okay, that would be a bad investment. It is a bad investment for this guy. All right, let me change a little bit of subjects here. The lesson actually had another part, another topic, if you wish, and it was about lighthouses. So if you can see from the the coastline of Europe, okay, let's see one. Okay, let's go to the northern Europe. So the coastline of Europe really is very intricate, very rugged. There's islands and rocks, that come out of, kind of in the middle of the sea and everything. And so because of that, let's see, Haley lives in North, by where that land, yeah. So, yeah, if you find faults, don't dwell on them. Okay, that's right. Yeah. So that is right, but the coastline of Europe presents a lot of challenges for ships, especially. All right, so if you are navigating in a boat, in a sailboat, or a cargo ship or something, you need to make sure that you are not going to bump into anything. And so people through the centuries, really, they have built lighthouses, okay, in order to tell sailors, especially navigators, where the coastline is. Okay, so here we have the article in Wikipedia on lighthouses, and it's beautiful because it has several pictures of lighthouses. This is a reconstruction and animation, a picture really of the first lighthouse that we know of in Pharos. So this was at the mouth of the Nile River by Alexandria. They actually found the lighthouse doesn't exist anymore, but they have found the remnants of this structure. Okay, so that would be the first lighthouse built. Okay, and lighthouses have been built, for hundreds of years in order to tell mariners, where these rocks come up. You can have actually even very small rocks, but that is enough to cause a huge wreck on a ship. Can you see here spring tide and the water level? This is the low water level, the high water level. Do you remember how we were talking in the science class about the tides? All right, so the lighthouse has to take that into consideration. This is in low water, is out, but in high water, you don't even see the rock, but it's still there enough to wreck you. Okay, yeah, very hard. Yeah. Yeah, well, there is one advantage. That this is an interesting thing. Most of these lighthouses, the base part is built out of concrete. Okay, and concrete actually hardens in water. Okay, so you can actually dump concrete under the water, and it will solidify in the water. Yeah. Yeah, yes. So that is why dams are sometimes built out of concrete and everything. And the shape, you can shape the concrete and it would stay, they put molds, okay? But even underwater, you can put and build structures of concrete underwater, okay? It is kind of backwards to think about that, and it's interesting. I actually find it to be a blessing. I don't have any other explanation. You have the physics that explain how that works and everything, but concrete is one of the only materials that actually hardens underwater. Okay. No. Every concrete is that way. To a certain point, but actually, it hardens also underwater. All right, so that is when you pour concrete, okay, you actually have to mix it with water, don't you? Okay, and you have to keep it wet until it hardens. Okay, so that is actually an important property of concrete. All right. I don't know of other things that do that. Okay, there might be, but concrete is actually a great blessing because it's very abundant. We are going to talk about this hymn in a minute, okay, Haley. But concrete is very, very abundant on the earth, and also is very useful because we can do all sorts of shapes and forms on that. Okay. That what the dam in Oklahoma is made of, and it's absolutely gigantic. Excellent, Charity. Yeah. Could you put water in a concrete box, then put more concrete on top? Would there still be there if you broke it years later? Yes, I believe that it would be. Okay. So, well, no, sorry. Oh, sorry, I'm reading this actually wrong. So if you put water in concrete in a concrete box, the water would actually seep through. So concrete is always porous, even though it may look hard. Okay, it actually hardens with water. Okay, but it absorbs the water. All right. So. but hardens. Yeah, but the structure, the molecular structure of concrete actually keeps bonding it. Okay, that is what happens. Okay.
And if it's on a shoreline or a river,
Mm-hmm.
I think you might lose
Yes, yes. So that is why you have to actually protect it until it hardens. You actually pour the concrete in a mold. Okay, and you just don't pour the concrete because it would just, the movement of the water and everything, it would make a mess. All right. That's right. Yeah, it would just dissolve it into the ocean and everything. So, okay. Yeah. So I really think that is a great blessing from God. Okay. The Romans discovered concrete many, many centuries ago. So the first structures of concrete were made by the Romans, and they discovered this property of limestone, that is one of the main components of concrete in the coast of Italy. Okay. Where do you get this stuff? Sam is asking, where do you get this stuff? Well, I study, I read, I learn all sorts of things all the time. Okay, so it's really, really interesting. That's right. Yeah, yeah. So whenever you think of anything, it's always everything is interesting to me. Okay, there's nothing boring. Okay, I actually find everything extremely interesting. This article on the lighthouses is fabulous. Really, these Fresnel lenses of the lighthouses are amazing. It's an amazing construction of how the lens is made by prisms that concentrate a very small beam of light, and it sends it horizontally out. Okay, so all these prisms, they concentrate and they bend the light in order to transfer horizontally, because you don't want the light just to diffuse all over in a lighthouse. You want it to project. Okay, and these Fresnel lenses, Fresnel was the guy that invented this type of lens, all right, and from France, and they are used all over the world. So they are really amazing. Yeah, so you learn everything about everything you can. Okay, it's a cool thing, really. Yep. So let me see. So the lighthouses are another interesting aspect of lighthouses is that you always have to keep them up to running. Okay, you never know when a ship is going to come, when is it going to need to see the light of the lighthouse. Okay, in the family school, this lesson, the lesson for today, be a lighthouse for the Lord, it includes actually several stories about lighthouse keepers, people that their job was to keep lighthouses. Okay, and it is a very generous profession, really, because imagine the people in the lighthouse usually live all by themselves. The lighthouses are yeah. So I feel very much related to Annika and Sam's dad. Okay, I like to learn a little bit of everything. Okay, so yeah. So the profession of being a lighthouse keeper is very generous, because you always have to maintain the lighthouse. They have to clean every part, all the crystal, the brass, and everything of the lighthouse every single day. Okay, because imagine that if you let the crystal become dirty, then the light won't shine through. Okay, most of the times these lighthouse keepers have to work through the night, because that is the time when the light is needed. Okay, so imagine you are all by yourself. Okay, no one says thanks, because the ships, you know, they see the light and everything. They may say, oh, thank you for the lighthouse, I found it, but you never receive that thanks. Okay, yeah. The salt water is very corrosive, so they have to maintain these lighthouses every single day, and it's something that has to be done by hand. The crystals are very fragile, okay? So by hand, everything has to be kept in line, okay, for the lighthouse to function properly. So Haley, you mentioned this hymn here, brightly beams our Father's mercy. I wish I could sing. Okay, I'm not a very good singer, but this hymn really talks about lighthouses. Okay, and it's very interesting. It compares really the mercy of Heavenly Father, okay, with the lighthouse. Because think about it, the lighthouse is there to guide the way, okay, but you don't know where the light is coming from, who is keeping the lighthouse, but it guides you. It tells you of where the danger is, okay? And so, and it says that the Father keeps the lighthouse, but to us he gives the keeping of the lights along the shore. All right? So what is that? What are the lights along the shore? So, and then in another part of this hymn, okay, they mention about the lower lights. Okay, let me see, is it here in this? Keep the lower lights. Okay, let the lower lights be burning. Let the lower lights be burning. What are the lowing lights? So the lighthouse is usually as high as possible on top of a hill, or you know, on top of the structure, okay? But then there are lower lights. They are not as bright as the lighthouse, but the lower lights are below, okay? And usually they are, if you have the lighthouse here, you have the lower lights here below, and they mark where the channel is to enter safely, okay? And so if you are on a boat here, you would see the light of the lighthouse, you know, in different areas. So you see, okay, there's something solid there, that's the lighthouse. But how should I approach the channel? The way to approach the channel is basically to align the lower light with the higher light of the lighthouse. Okay, so if you are here, you would see that the lower light is not aligned. Okay, so you are not pointing to the channel. So you would move until the lower light is aligned, is vertically aligned with the higher light of the lighthouse, and then you would know this is how to go in. Okay, so he says, the hymn basically says that he keeps, you know, for us, we are in charge of the lower lights. Okay, he gives us charge, he gives us the keeping of the lights along the shore. So he is the big light, okay, the lighthouse. We are, as his servants, the ones keeping the lower lights, guiding others to safety. Does that make sense? Okay. Let me see some of the comments here okay. Yeah, he is our lighthouse, our personal part of the light of Christ. So we reflect the light of Christ, okay? And that is what keeps our lower lights burning. The ones below, so the ships, when they get closer, cannot hit the rocks. Yes, so the lights along the shore are also indicating, remember in last week's class when I was talking about going through the channel, So you have the buoys with lights that indicated the safe area. Yeah. Excellent, Haley. You're getting that. That's absolutely right. Okay, so this is like Annika, you say in Carry On, Mr. Bowditch. All right. It was incredible, since they often don't have all the lights, but they make it safely through. So, the entrance, for example, to Boston, this was the area where Mr. Bowditch had to go in, is very difficult. It's very, very difficult harbor to find and everything. And sometimes there's lots of fog. So with the fog, you didn't have lights, you couldn't see the lights of lighthouses and everything, so it becomes a lot more dangerous. Okay, there's lots of symbolism here, and also you see how the mirrors reflects the lights from the lighthouse. Beautiful. The mirrors and the crystals, they have to be kept clean. Can you see also that how is a symbolism of how we need to be clean in order to reflect and project the light of Christ? If we are not clean, okay, we cannot project. The light diffuses. We are not good for much. All right. So one of the activities that I have here for you for this class, let me see if I have it. Okay, here. So one of the activities is to get the maps. Another one is to do a family home evening about this hymn. Okay, and you can explain and talk with your family about all these symbolisms, all the things that you have learned, and you can teach to your family about lighthouses and about the higher lights and the lower lights, the lights along the shore and so on, and see what you can learn together about that. Okay. The favorite part in the song is, I really love this part. So some poor, fainting, struggling seaman you may rescue, you may save. Sorry guys, but there's really no higher joy than sharing the gospel of Jesus Christ to someone that is struggling. There's really nothing more beautiful than to be able to share the gospel, to reflect the light of Christ, so you can help someone else. And I hope that each one of us could be better instruments for God in doing that. In the name of Jesus Christ, amen. Thank you. Charity, you said that your brother gave a farewell talk on lighthouses and lanterns and the hymns. Yeah, okay. With a different metaphor. I would love to see that, to hear that. Okay. Excellent. Rodney, would you like to say a prayer to finish class? Thank you.
We're thankful for the blessings of thy Spirit and the blessings of the gospel and the many things we've been able to learn, for all the knowledge that we have. We're thankful for everyone we know, for our teachers, everyone that's in the class. We're grateful that we can all learn and participate together. Please help us to learn and to grow, to work hard and be able to listen and learn. Help us in all of our daily struggles. In thy Son, Jesus Christ. Amen.
Amen. Thank you very, very much. I have really enjoyed the class. We'll see you next week.